Before we begin, I want you to imagine something impossible. Picture Earth. Not the blue planet you know, not oceans, not clouds, not life. Imagine a world with no seas, no rivers, no rain, no waves crashing against shorelines. A planet of fire, dust, and silence. Because there was a time, a very real time, when Earth had no oceans at all. Welcome to Earth's archive. If you love deep history, cosmic mysteries, and the hidden story of our planet, you're in the right place. Today, we're traveling back to a time before water ruled Earth. Stay with me, because what you're about to hear completely changes how you see the oceans, and how close Earth came to becoming a dead world forever. Earth formed about 4.54 billion years ago. But this young Earth was nothing like the calm, life-filled world we live on today. It was violent, it was unstable, and it was brutally hostile. Imagine a planet still under construction. The surface wasn't solid ground. It was molten rock. Entire continents were oceans of lava. The sky wasn't blue, it was thick, choking, and poisonous. No oxygen, no clouds, no rain, just ash, gas, and fire. This was Earth's earliest chapter, a chapter so extreme that no water could exist on the surface. Any water that tried to appear was instantly vaporized, boiled away, destroyed. At this stage, Earth was constantly being bombarded. Asteroids, meteorites, planetary debris. The solar system was chaos. There were no stable orbits, no peace. Every collision released enough energy to melt rock and reset the planet again and again. Scientists call this period the Hadean Eon. Hadean, named after Hades, the Greek god of the underworld, and honestly, the name fits perfectly. Because Earth was literally hell. Now here's something most people don't realize. Water did exist in the solar system back then, but Earth couldn't hold on to it. Why? Because Earth was too hot, and its gravity was still stabilizing. Any water molecules that formed were ripped apart by heat, or blown into space by violent solar winds. So, while the building blocks of oceans were present, Earth remained dry. Scorched planet with no seas, no rain, and no future for life. At least, that's how it seemed. But something remarkable was happening beneath the surface. As Earth slowly cooled, just a little, volcanoes began to dominate the planet. Not small volcanoes like today. We're talking about planet-wide volcanic activity. The ground cracked. Magma erupted everywhere, and with those eruptions came gases trapped deep inside Earth. Water vapor, carbon dioxide, nitrogen. Volcanoes were leaking the ingredients of oceans into the sky. But still, there was a problem: the temperature. Earth was still too hot for water to stay liquid. So instead of oceans forming, Earth developed a thick, steam-filled atmosphere. Imagine standing on the surface. You wouldn't see stars. You wouldn't see the sun. The sky was completely wrapped in dense vapor. Earth had an atmosphere made of future oceans, but they hadn't fallen yet. For millions of years, maybe tens of millions, Earth existed like this. A dry surface below, and oceans waiting in the sky. Then something changed. Slowly, almost imperceptibly, the planet cooled. The molten crust began to harden, and temperatures dropped just enough for something miraculous to happen. Rain. Not gentle rain, not storms, but planet-wide rainfall that lasted thousands of years. Imagine rain so heavy, it never stops for centuries, for millennia. This wasn't weather, this was Earth creating its oceans. The first drops hit scorching rock. They instantly turned to steam, but the rain kept coming, and coming, and coming. Eventually, the surface cooled enough for water to remain liquid. Tiny pools formed. They merged. They spread. Low points on the planet filled first, basin by basin, crack by crack, until the first true oceans were born. But these oceans were nothing like today's. They were acidic, hot, toxic, and lifeless. At least, at first. But let's pause here. Because there's a mystery scientists are still debating. Where did Earth's water really come from? Was it all released by volcanoes, or did something else deliver it? Some researchers believe that a massive amount of Earth's water came from asteroids and comets, ancient space rocks packed with ice, slamming into Earth again and again, each impact delivering more water, more hydrogen, more oxygen. If that's true, then Earth's oceans are literally from outer space, born from cosmic collisions. Think about that. Every ocean wave, every drop of rain, may have begun its journey far beyond Earth itself. But here's the terrifying part. Earth almost lost everything. During a period called the Late Heavy Bombardment, around 4 billion years ago, Earth was smashed repeatedly. Impacts so powerful they could have boiled the oceans away again, resetting the planet back to zero. And for a while, it looked like that might happen. The oceans were fragile, young, unstable. One wrong event, and Earth would return to a dry, dead world, but somehow, against impossible odds, the oceans survived, and once they did, everything changed. Because water isn't just liquid. Water is a chemical miracle. It absorbs heat, it stabilizes climate, it allows complex chemistry. The oceans cooled Earth further, they created weather, they shaped continents, they became the cradle of life. But that story is only just beginning. Because the first oceans weren't friendly. They were hostile, violent, and deadly, and yet, somehow, life still found a way. When the first oceans finally formed, Earth did not become peaceful. In fact, the most dangerous chapter of our planet's history was just beginning. Because these were not blue oceans. They were not calm. They were not life-friendly. They were hot, acidic, violent seas, and they were constantly trying to erase themselves. Imagine standing at the edge of Earth's first ocean. The water is dark, almost black. Steam rises constantly. The air smells of sulfur and metal. The temperature is unbearable. This is not a place meant for life. And yet, this is where everything began. The early oceans were heated from below by a planet that was still cooling. Magma. Chambers sat just beneath the crust. Volcanoes erupted non-stop. Entire sections of the ocean floor split open, releasing superheated water rich in chemicals. These underwater volcanic systems, called hydrothermal vents, turned the oceans into chemical reactors. Water mixed with minerals. Heat-powered reactions. The oceans weren't just water anymore. They were alive with chemistry. But they were also deadly. Lightning storms ripped across the sky. The atmosphere was thick with carbon dioxide, methane, ammonia, oxygen was almost non-existent. Ultraviolet. Radiation from the young sun poured down unfiltered. There was no ozone layer. Every day, Earth was being bombarded by radiation powerful enough to destroy complex molecules. So here's the question scientists still struggle with. How did life survive? Long enough to begin, the answer may lie in the deepest, darkest parts of the ocean. Far below the surface, where sunlight could not reach, where radiation was blocked by kilometers of water, life may have found shelter. At hydrothermal vents, chemical energy replaced sunlight. Instead of photosynthesis, early life used chemosynthesis. Energy from Earth itself. In other words, life did not begin because Earth was gentle. Life began because Earth was violent. But before life could truly take hold, Earth faced another massive threat, one that could have erased the oceans entirely. The young sun. Early in its life, the sun was unstable. It released intense solar flares, powerful radiation storms, and violent solar winds. These winds slammed into Earth's atmosphere. Without protection, they could have stripped it away, taking the oceans with it. Mars likely suffered this fate. It once had rivers, lakes, possibly oceans, but it lost its magnetic field. And when that happened, the sun slowly peeled its atmosphere away. Earth came terrifyingly close to the same destiny. So why didn't Earth lose its oceans? Because deep inside the planet, something extraordinary was happening. Earth's molten core was spinning. That spinning created a magnetic field, an invisible shield. This magnetic field deflected solar wind, protected the atmosphere, and locked the oceans in place. Without it, Earth would be dry today. No oceans, no life, just another dead rock in space. Every wave you see today exists because Earth's core never stopped spinning. As the ocean stabilized, another transformation began. Rain cycles formed, clouds thickened, weather patterns emerged. For the first time in Earth's history, water moved continuously, from ocean to sky to land and back again. This cycle reshaped the planet. Water carved valleys, formed rivers, ground mountains into sediment. The continents were no longer raw rock. They were evolving, but the oceans were still hostile, extremely salty, highly acidic, loaded with dissolved metals. If you fell into them, survival would be impossible. Yet, somehow, life didn't just survive, it adapted. The earliest life forms were simple, single-celled organisms. No eyes, no brains, no movement, but they had one powerful advantage. They multiplied. Trillions upon trillions of microscopic organisms spread through the oceans, and slowly, they began to change the planet itself. Some developed the ability to use sunlight. Photosynthesis. They absorbed carbon dioxide and released oxygen. At first, oxygen was poison. It reacted violently with ocean minerals, rusting the seas. Literally, this period is known as the Great Oxidation Event. Oxygen levels rose. And for most early life, this was catastrophic. Entire ecosystems collapsed, mass extinction on a microscopic scale. But again, life adapted. Oxygen transformed the oceans, and eventually, the atmosphere. The sky changed color, from orange haze to pale blue. The sun's radiation weakened at the surface. The ozone layer formed. Earth became safer, calmer, more stable. But this stability came at a price. Life was no longer hidden. Now it had to compete, evolve, innovate. The oceans deepened, they cooled, they separated into layers. Warm surface waters, cold, deep waters. Currents formed. These currents distributed heat around the planet, preventing extreme temperature swings. This is why Earth didn't freeze solid or overheat completely. The oceans became Earth's climate engine. Without them, the planet would swing wildly between extremes, just like Venus or Mars. By now, Earth was no longer a fire world, it was a water world. But remember, this almost didn't happen. If Earth had cooled slower, the oceans would never have condensed. If the sun had been more violent, they would have been stripped away. If Earth's core had stopped spinning, everything would have been lost. Earth balanced on a knife edge, and somehow it stayed there. By the time Earth's oceans had settled, cooled, and begun shaping the planet, it looked like the worst was over. But Earth wasn't done testing life yet. In fact, one of the most extreme events in planetary history was about to begin. An event so severe that the oceans themselves nearly vanished again. This time, not by fire, but by ice. Imagine standing on Earth as temperatures begin to fall, not slowly, relentlessly, year after year. The sun still shines, but something is wrong. Less heat is staying on the surface. More light is being reflected back into space. Ice begins to form at the poles. At first, it seems harmless, but ice has a dangerous property. It reflects sunlight, and the more ice forms, the colder Earth becomes. This creates a runaway effect. Ice spreads, temperatures drop further, more ice forms. This feedback loop spirals out of control. Earth is sliding toward a frozen nightmare. Scientists call this the snowball Earth hypothesis. And, according to geological evidence, it actually happened. More than once. Between about 720 and 635 million years ago, Earth may have frozen almost completely. Oceans locked beneath kilometers of ice. Continents buried, life trapped in darkness. From space, Earth would not have looked blue. It would have looked white, a frozen marble drifting through space. Now here's the terrifying part. If the oceans had frozen solid, life would have ended. No liquid water, no chemistry, no survival. But somehow, the oceans didn't fully freeze. Even under a global ice shell, liquid water still existed below. Why? Because Earth never stopped releasing heat. Deep beneath the crust, radioactive decay and residual heat from formation continued. This geothermal heat kept the deepest oceans liquid. Hydrothermal vents still flowed, chemical energy still existed. Life retreated, but it did not disappear. In these dark oceans, life adapted again. Photosynthesis became impossible. Sunlight could not penetrate thick ice, so life returned to chemosynthesis, depending on Earth's internal energy. Once again, life survived not because conditions were good, but because Earth was active. But snowball Earth couldn't last forever. Volcanoes continued erupting, even under ice. They pumped massive amounts of carbon dioxide into the atmosphere. Normally, oceans absorb CO2. But with oceans sealed beneath ice, CO2 accumulated, trapped, building up over millions of years. The greenhouse effect intensified, temperatures began to rise. Slowly, then rapidly. When the ice finally began to melt, the result was catastrophic. Global temperatures spiked. Ice melted at incredible rates. Sea levels rose violently. The planet shifted from frozen to flooded in geological moments. This sudden warming reshaped continents, created massive erosion, and reloaded the oceans with nutrients. Nutrients life desperately needed. This period may have triggered one of the greatest explosions of life in Earth's history. Complex multicellular organisms began appearing. Life grew larger, more diverse, more experimental. The oceans transformed from survival zones into evolutionary laboratories. Predators emerged, defense mechanisms followed. Eyes, movement, shells. Life accelerated, but Earth was still not stable. Ocean chemistry fluctuated. Oxygen levels rose and fell. Mass extinctions occurred again and again, each time wiping out dominant species. Each time giving new life forms a chance. The oceans became a testing ground, adapt or vanish. By now, Earth was undeniably a water planet. Oceans covered more than 70% of its surface. They regulated temperature, shaped climate, connected ecosystems across the globe. Without oceans, Earth would resemble Mars, cold, dry, dead. Instead, it became alive, but even now, the oceans were not guaranteed. They still depended on a delicate balance. Solar output, atmospheric composition, geological activity. One shift, and everything could change again. And that brings us to today. Modern Earth, a planet that looks stable, but isn't. Because the oceans are still changing, still responding, still vulnerable. And understanding how Earth once had no oceans helps us understand how easily we could lose them again. By now, you've seen something most people never think about. The oceans were not guaranteed. They were not permanent. They were not inevitable. Earth existed for a long time without them. A dry world, a burning world, a silent world, and every ocean. Wave you see today exists only because a series of impossibly delicate events went exactly right. But here's the most important truth of all. Earth is not done changing. We often look at oceans as eternal, as if they've always been here, as if they always will be. But Earth's history tells a very different story. Oceans can appear, and oceans can disappear. They have frozen, they have boiled, they have nearly vanished, and they can change again. Right now, Earth's oceans control almost everything about life. They absorb heat from the sun. They store carbon dioxide. They regulate climate. They drive weather systems. Without oceans, Earth would experience temperature extremes so severe that complex life couldn't survive. Daytime heat would scorch the surface. Nighttime cold would freeze it solid. No balance. No stability. No civilization. Think about this. Every breath you take is connected to the ocean. Phytoplankton, microscopic life in the sea, produce over half of the oxygen you breathe. Not forests, not trees. The ocean, and yet, for most of Earth's existence, none of this existed. No oxygen-rich seas, no life-filled waters, no blue planet. Just a rocky world struggling to hold itself together. So what would happen if Earth lost its oceans again? Not overnight, but slowly. As temperatures rise, as ice melts, as chemistry shifts, the balance begins to tilt. Warmer oceans absorb less carbon dioxide. That accelerates warming. Ice disappears. Sea levels rise. Currents weaken. Weather patterns destabilize. The same oceans that once saved Earth can also amplify change. Earth has been here before. Rapid warming, sudden climate shifts, mass extinctions. The difference now is us. For the first time in Earth's history, a species understands what's happening. We know Earth once had no oceans. We know how fragile they are. We know what happens when balance breaks. And that knowledge comes with responsibility. When you look at the ocean today, you're not just looking at water. You're looking at 4 billion years of survival. You're looking at volcanic steam turning into rain, at asteroids delivering ice, at frozen worlds thawing, at life refusing to disappear. The oceans are Earth's memory. They carry the scars of every catastrophe and every recovery. This is why Earth is different from Mars. Mars lost its water, lost its atmosphere, lost its magnetic shield. Earth didn't, and the oceans are the reason. They protected life long enough for intelligence to emerge, long enough for you to sit here, watching this video, thinking about a world that existed billions of years before you were born. And here's something truly humbling. One day, Earth will lose its oceans. Not tomorrow. Not soon, but billions of years from now. As the sun grows brighter, as water slowly escapes into space, the oceans will evaporate. Just as they once didn't exist. They will vanish again. Earth will return to silence, a rocky world beneath an aging star. But until that day, this moment matters. Because we are living during Earth's ocean age, a rare chapter, a fragile chapter, a beautiful chapter, and understanding where the oceans came from helps us understand why they matter so deeply. If this video changed the way you see Earth, then Earth's archive is exactly where you belong. This channel exists to explore the forgotten history of our planet, the deep past, the cosmic forces, the stories written in stone, water, and time. In upcoming videos, we'll explore how Earth nearly became like Venus, why oxygen almost wiped out life, what would happen if Earth stopped spinning, and how tiny changes can reshape entire planets. So, make sure you stay tuned. Stay with us, because Earth still has many secrets left to reveal.